Okay, so students, today we are going to see the application of bits. Already in the previous lecture, we have seen how the bits are formed. So for the formation of bits, we have seen the condition. Condition is there is a requirement of two progressive waves. They will be traveling along the same direction with same amplitude but slightly difference in frequency. When such two progressive waves will get superimposed on each other, then we will get the resultant progressive wave, which consists of successive maximum intensity point, which is to be called as a waxing, and minimum intensity point, that is waning. Means at waxing point, the sound intensity is maximum, and at waning point, the sound intensity is minimum. So that alternate waxing and waning gives us the formation of bits. And also in that lecture, we have seen the frequency of bits, period of bit. So we have seen the period of bit t is equal to nothing but 1 upon and 1 minus n. And also we have seen the frequency of bits is nothing but frequency of bits capital N is equal to nothing but n1 minus, right? Now, where that bit phenomenon is going to be used, that we have to see under this application as the applications of bits. Now, in that, the first application of bits, where this bits concept we are going to use in the practical life. So the first concept which we are going to use in the orchestra. So in the orchestra, the different musical instruments are going to be played at a time. Now there is a drum. So drum means when anybody is putting a hands on that drum, his air column inside the drum will start vibrating. Someone is playing with guitar string, means that is the string vibration. So string vibration frequency and air column frequency, these are the two different frequencies. So when the two instruments in the orchestras are going to be played at a time, and if their frequency difference will be coming to be small, then the bits will progress. Means you will get the pleasant voice of the music. So the bit frequency between that two orchestra instruments will be less. So automatically you will get the pleasant voice. You can enjoy that music in the orchestra. So that is nothing but the first application. The first application is nothing but while playing musical instruments, we can test the benefit of this application, which is to be called as a bits. Clear? Second thing, so many times for this musical instrument, I can give one more application. You have seen the Zakir Hussain Tabla Vadan as a live show. So in that live show, along with Zakir Hussain, someone is going to be playing with guitar, or there will be a flute or basuri vadan is there. So basuri is going to be played, means again air column vibration will take place. Zakir Hussain tabla is going on, that is also air column vibration. So the two frequencies are different, totally different. Then you will not enjoy that music, because you will get two different sound waves. They are going as through the medium. They are not going to be co-current with each other. So you can't enjoy that music. But if the Zakir Hussain tabla vadan frequency matches with slightly different than that of the basuri frequency, then the bit formation frequency will be less and you can enjoy that music. So there we are going to use the concept of this as a bit frequency. The second application of this bit frequency is nothing but in the determination of somewhere you have seen the instrument which is to be called as a radar. So by this radar instrument, we can find out the speed of aeroplane, right? So in that determination of speed of aeroplane, we can use the concept of bits. Now, how we are going to use that concept of bits? There we are going to use the concept of Doppler effect. Now, already we have seen the Doppler effect. What is the Doppler effect? Whenever there is a relative motion between source of sound and the listener, then there will be the change in apparent frequency, and that change in apparent frequency is to be called as a Doppler effect. So that change in apparent frequency, that is Doppler effect concept, is used in the radar, and that change in apparent frequency gives us the formation of bits, and by that we can able to determine the speed of airflow. The another concept which we can consider, that is nothing but as in the traffic police. So you have seen the speed gun of traffic police. So in that speed gun of traffic police, again we are going to use this concept of bit application. How we are going to use the bit application concept? So that speed gun is want to be limit the speed of vehicle. So speed of vehicle can be determined with the help of this speed gun. Is it right? So what is the thing? Speed gun will emit some microwave. So that frequency, and when vehicle is going on, so that vehicle frequency. So if there is a large difference in the frequency, so bit will not going to be produced. But if that frequency will be less, then there will be a formation of bits. And then by that formation of bits, we can determine that speed of that particular vehicle. And if that speed of vehicle will cross the limit, then what I can say that, then that particular person will get somewhat in the next what I can say signal, that vehicle will be taken aside by the traffic police. That speed is maximum as compared to that of given the speed. So by that manner we can control on a traffic, and by using this bit application. Also, the fourth application is nothing but you have seen the Doppler sonography. This Doppler sonography is the medical application. So in that medical application, Doppler sonography is there. Might be you have heard that pregnant lady, the what I can say that the heartbeats of the baby will be counted with the help of this Doppler sonography. So heartbeats means there is a sound waves. So that sound waves are get captured with the help of microwave signal. So if their frequencies are frequency difference is very less, then maximum sound and minimum sound alternately will be heard. That is waxing and winning will be produced. And then we can catch the, what I can say that, heartbeats of that baby. So that is nothing but as a Doppler sonography. So by that, here also we are going to use the bit frequency. Clear? Then might be you have heard about the another concept, that is nothing but the ultrasonography, Doppler ultrasonography. This or echocardiogram. So in that echocardiogram, what the thing is there? The speed of blood flow will be measured. That speed of blood flow in the human body will be also used with the help of this concept of bit frequency. So these are the important applications. At the same time, we can determine the frequency of unknown sound node. The unknown frequency can be determined with the help of concept of bit. So in sonometer experiment, I have explained you the pepper-adder method. If you are remembering in that sonography, sonometer experiment, what we are saying that there is one string which will be attached to the one rigid support, another end will be passes over the hanger, other end hanger is attached, and that string will be rest on the pulley, rest will on the knife edges, and the distance between that knife edges will be acting as a vibrating. And what we want, there should be a production of fundamental frequency. The string should vibrate with fundamental frequency, and when string vibrate with fundamental frequency, at the center of the string, antinode will be produced. And that production of antinode will be detected with the help of paper identity. Clear? Instead of that, there we can use the bit frequency. Now how? The persons who are very good in the musical sense, what they will do, they will hammer the tuning fork on the rubber pad, touch and just hear that frequency, and same frequency state will be touched to the air column, that is sonometer box. So air column inside that sonometer box will start vibrating. So that sound wave frequency and the actual frequency of the tuning fork. The persons whose ears are very good in the musical sense, they can detect the difference in the frequency. And slowly they can reduce that frequency difference. And when both the frequencies are same, so resonance will occur. And what happens? External periodic frequency of the tuning fork will exactly matches with the string frequency. So the string will vibrate with maximum amplitude, and that length we are going to consider as a vibrating string. So at that time, what we can say, that string frequency is exactly equal to the external tuning fork frequency, and by that manner we can find out the of that particular tuning fork. So there also we can use the bit application, right? So depending on that, there will be a 2-mark question. Take applications of the bits. Clear? So these are the applications of bit. If anybody will ask for the explanation, you should be able to explain that concept, how the bit frequency concept is used in this application. Clear? So this bit concept is connected with medical instruments. So might be you are knowing there is an instrumentational engineering branch in there, and in that instrumental engineering branch, the technical knowledge, physics instruments are related with medical science. So physics principles are to be used in every medical instrument, and that medical instrument is used to check our diagnosis of the different diseases. So right that biology and physics are correlated to each other in the branch of physics, which is called as the instrumentation engineering, or it is to be called as a biomedical engineering. Is it right? So every physics basic concept which you are going to study in the 12th standard, that are going to be used in your next knowledge of engineering as well as in the medical. Fine? And here your chapter as a superposition of waves is finished. And now we can discuss whatever the remaining problem. So already we have seen the problems in the previous lecture. Some problems are remaining, so that I am going to discuss today. So I think last time I have taken the numerical problem up till problem number 19, right? And now I am going to start the problem number 20. So see that in the problem number 20, it is given that the violin string vibrates with fundamental frequency of 440 Hz. Now violin string means here you have given the concept of vibration of string, and in that concept of vibration of string you have given your fundamental frequency is nothing but 440 Hz. And in the theoretical concept, what we are knowing that when string vibrates, that string will vibrate with all integral multiple of fundamental frequency. Means the string fundamental frequency n, then its first order term frequency is 2n, its second order term frequency is 3n. Like that manner, its order term frequency is nothing but 2. So this basic hearing knowledge you have to recall. That is, string vibrates means string will vibrate with all integral multiple of fundamental frequency. Clear? And now see the next part of the problem. What you want to calculate? You want to calculate what are the frequencies of first and second order. Right? Now first overtone. Which is first overtone frequency? First overtone frequency is nothing but your 2n. Right? Means what I can say that first overtone frequency, which is equal to 2n, which can be written as 2 into 440, means your first overtone frequency answer is nothing but 880 Hz. Right? Similarly, second overtone frequency. This is your second overtone frequency. So this second overtone frequency, which is equal to 3n, which can be written as 3 multiplied by n is the fundamental frequency, which is 440. Just do the product. So 3 zeros are 0, 3 fours are 12, 1 carry, 12 plus 1 13. So your second overtone frequency value is nothing but 1300. So this is your MCQ question, not 2 marks. It is so simple. So such type of question either comes in MCQs or very short answer or 2 mark question. Clear? So just from this problem, recall your 3 sentences. When string vibrates, it will vibrate with all integral multiple of fundamental frequency. And when air column will vibrate, at that time, when air column will start vibrating, and if that air column pipe will be closed at one end, at that time it will vibrate with odd integral multiple of fundamental frequency. And when pipe is open at both the ends, at that time air column will vibrate with all integral multiple of fundamental frequency. So these 3 sentences you have to remember very carefully while solving the numerical problems. Fine. So now I can switch over to the next problem. That is your problem number 21. So just read that problem number 21. And in that problem number 21, just wait. You read it, so I will explain afterward. So you have given a set of 8 tuning probes is arranged in series of increasing order frequencies. So you have given a set of 8 tuning probes. So what I can say that 8 tuning probes. So N1, then N2, then N3, like that manner 8 tuning probes are ordered, are arranged in the increasing frequency manner, in increasing order. That is given first point. What is the second thing given? Each probe will give 4 bits per second with the next one. Each tuning probe will give 4 bits with the next frequency. Means increasing order means what I can say that N1 is less than that of N2, N2 is less than that of N3, like that manner less than that of N8. Means always successive frequency is more. Means what I can say that N2 minus N1 is equal to 2. Or I can say that N3 minus N2 is equal to 2. If it is so, what I write down here, N3 is equal to 4 plus N2. And what I am getting here from first equation, this is my equation 1, this is my equation 2. So from equation 2, I will write down N3 is equal to 4 plus N2. In that equation, I can use equation 1. What value of N2 I will get? N2 is equal to 4 plus N1. So that I will put 4 plus N1. Means what I will get it here? 8 plus N1. Got it? This 8 I can write down 4 multiplied by 2 plus N1. So this is nothing but your N figure. Now just see the sequence. What we want to determine? N2. What is 4? 4 is a bit frequency. 4 is multiplied by 2. This 2 number is less than 1 from this third frequency. Plus, are you getting? Means like that manner if I want to write N4. What I write? N4. 4 में से 1 गया. How much? 3. So what I say, 4 is a bit frequency multiplied by 3 plus n. Are you getting how to write the next frequency? Similarly, I can write n5. See here, n5. How I can write? यहाँ पे नंबर क्या है 5. 5 में से एक गया, कितना बचा 4. बिट फ्रीक्वेंसी कितनी है 4. उसको मल्टीप्लाई कितने से करेंगे 4 से प्लस. So like that manner I can write n8. यहाँ क्या है 8. 8 में से एक गया मीन्स 7. So 4 multiplied by 7 plus n. इसमें 4 क्या है 4 is the frequency. तो ये हो गया मेरा very second important equation. Is it right? So this is my equation 8. How I have written? I have written from the concept whatever data is given. कौन सा डेटा से लिया? Increasing order में है, bit frequency 4 है. From that I have written the value of n8. Clear? Fine. Next, what is given next thing? You have given the frequency of last probe is twice that of first. Last कौन सा है n8. It's twice that of first. Twice first means twice. यह हो गया मेरा इक्वेशन. Okay. And now I have to find out what I want to determine. I want to determine the frequency of first and frequency of last. Means मुझे n1 and n8 determine करना है. So I'll equate these both equations. Fine. So I'll say twice n1 is equal to 4 into 7, 28 plus n1. So I write twice n1 minus n1 is equal to 28. So n1 is equal to 28 hertz. That is my first frequency. Frequency of first connection. And what I want to find? Frequency of last one. Last is कौन सा आपका n8. और n8 and n1 में क्या relation है? n8 is equal to twice n1 means twice into 28 which is equal to 56 hertz. हो गया मेरा second problem. Right? So like that manner you can solve this problem. ये आपको बोर्ड एग्जाम में 3 मार्क्स के दिया. तो यहाँ पे अगर इंक्रीजिंग दिया है, अभी सपोज डिक्रीजिंग में होगा तो क्या होगा? रिवर्स प्रोसेस फॉलो करेंगे. राइट? द कंसेप्ट विल रिमेन. Next, problem number 22. Now in this problem number 22, you have given a sonometer wire is stretched by a tension of 40 Newton. Sonometer wire के लिए हमने 40 Newton that much tension I have applied. Clear? So that tension factor you have given as a 40 Newton. 40 न्यूटन इतना टेंशन मैंने अप्लाई किया है. तो टेंशन T is equal to 40 न्यूटन. Let me clear this board first so you can able to see clearly. Okay, tension how much is applied? Tension T is equal to 40 न्यूटन इतना अप्लाई किया है. Okay, fine. It vibrates in unison with tuning probe frequency 384. Tuning probe frequency capital N 384 is unison with small n. Capital N is the frequency of tuning probe, small n is the frequency of string. Unison word दिया है. Unison का मतलब क्या है? External tuning probe frequency is equal to the frequency of string. That's why I have written this. Right? इसमें कैपिटल M है आपका फ्रीक्वेंसी ऑफ ट्यूनिंग प्रोब एंड the small n is nothing but the frequency of string. Got it? Fine. आगे क्या दिया आपको? How many number of bits get produced in 2 seconds if the tension in the wire is decreased by 1.24 Newton. Means अगर मेरा ये टेंशन T1 40 न्यूटन था, अभी मैं कितना करूंगी T2. T2 will be what? Decreased by 1.24 Newton. 24 न्यूटन से अगर टेंशन डिक्रीज करेंगे तो व्हाट आई एम गेटिंग दिस T2 I am getting as a 38 point, I will get it here as a 72. अगर मैंने टेंशन डिक्रीज किया तो वी आर नोइंग दैट फ्रीक्वेंसी इज इनवर्सली प्रोपोर्शनल टू रूट टी। अगर मेरा टेंशन डिक्रीज हो गया तो न्यू वाली फ्रीक्वेंसी क्या होगी, डिक्रीज होगी। मींस व्हाट आई से दैट फर्स्ट फ्रीक्वेंसी n1 डायरेक्टली प्रोपोर्शनल टू t1, सेकंड फ्रीक्वेंसी n2 डायरेक्टली प्रोपोर्शनल टू। इसका मतलब जब मेरा 40 न्यूटन टेंशन है, at that time string will vibrate with frequency n1। वही टेंशन मैंने 1.28 न्यूटन से डिक्रीज किया तो ऑटोमेटिकली द फ्रीक्वेंसी ऑफ वाइब्रेटिंग स्ट्रिंग विल डिक्रीज, दैट इज n2। तो तब उसमें हाउ मेनी बिट्स आर प्रोड्यूस्ड इन 2 सेकंड, तब बिट फ्रीक्वेंसी इन 2 सेकंड आपको कैलकुलेट करना है। तो इसका मतलब क्या है, फर्स्ट I want to determine subtraction n1 and n2 मुझे पता होना चाहिए, ठीक है। तो I'll take ratio, इन दोनों का अगर मैंने रेशियो लिया तो what I'll get it रेशियो में n1 upon n2 is equal to root of t1 by t2। इसमें से मुझे n1 पता है, ओरिजिनल फ्रीक्वेंसी ये n1 थी, ये पता है कितना है मुझे 380। तो what I'll say here n2, अगर मुझे n2 निकालना है तो what I'll say square root of T2 by T1 multiplied by n। ये मैंने रिवर्स किया because I want to find out n2। Clear? Now I will put the value. See here, n2 is equal to under root of T2 मेरा कितना है 38.72 upon 40 multiplied by n1 frequency मेरी 380। अभी ये मुझे डिवाइड करना है, डिवाइड करके मुझे इसका स्क्वायर रूट निकालना है। क्लियर? सो व्हाट आई डू हियर, आई कैन फर्स्ट आई विल डू द डिवीजन। अगर मैंने उनका डिवीजन किया, इज इट राइट, तो बाय दैट डिवीजन आई विल फाइंड आउट हियर, इसका डिवीजन करना है मुझे। तो इसका डिवीजन करने के लिए आई हैव टू टेक द हेल्प ऑफ लॉग टेबल, एंड इफ आई टेक द हेल्प ऑफ लॉग टेबल एट दैट टाइम I will get this concept as a, okay, I'll do that calculation, that is what is the difference, division of this 38.72 divided by 40। this division, ये मेरा division आएगा square root of 0.968 multiplied by 380। क्लियर? अभी इसका स्क्वायर रूट निकालना है मुझे, सो आई विल फाइंड आउट द स्क्वायर रूट। तो मुझे वापस लॉग बुक रिफर करना पड़ेगा, लॉग बुक रिफर करके 0.968 इसका स्क्वायर रूट आ गया 0.9838 मल्टीप्लाइड बाय 384। ये किया मैंने, तो ये सब करने के बाद आई विल गेट इट n2 is equal to, मुझे n2 की वैल्यू मिलती है 377.95 हर्ट्ज। सो विच इज इक्विवेलेंट टू n2 वैल्यू मिलेगी मुझे 378 हर्ट्ज। ये मुझे n2 मिला। नाउ व्हाट आई फाइंड बिट फ्रीक्वेंसी, n is equal to n1 minus n2। n1 कितना है मेरा ऑलरेडी 384 minus 373 means I am getting bit frequency 6 hertz। लेकिन बिट फ्रीक्वेंसी का मतलब क्या है, नंबर ऑफ बिट्स हर्ड इन 1 सेकेंड। तो एक सेकेंड में मुझे 6 बिट्स सुनाई दे रहे हैं, तो 2 सेकेंड में बिट्स हर्ड इन 2 सेकेंड, बिट्स हर्ड इन 2 सेकेंड will be nothing but 6 multiplied by 2 which is nothing but your 12 seconds। तो मुझे यहाँ पे 12 सेकेंड, not 12 सेकेंड, I will get the 12 bits। यहाँ पे मुझे मिलेंगे 12 bits। Clear? Okay. Then your problem number 23. In that problem number 23, the problem is sonometer wire of length 0.5 meter is stretched by weight of 5 kg the fundamental frequency of vibration is 100 hertz, then calculate the linear density of the wire. ये तो बहुत easy वाला problem है. So you have given fundamental frequency, you have given the vibrating length. So I write sonometer length 0.5 meter, that is given. Then you have given weight. So weight means alpine tension is equal to mg, which is equal to 5 into 9.8, that much Newton. इसके बाद है आपको fundamental frequency L, which is given 100 hertz. And what I want to calculate, linear density, that is small m, that I want to determine. So now I write fundamental frequency formula for a string, n is equal to 1 upon 2L under root of T by n. This is the basic formula. मुझे क्या डिटरमाइन करना है? स्मॉल. तो इसका मतलब मुझे स्मॉल m जो अंडर रूट में है उसको अंडर रूट से बाहर निकालना है. तो L स्क्वायर बोलते हैं. अगर मैंने स्क्वायर किया तो बोला ये m स्क्वायर is equal to 1 upon 4L square T by n. अभी मुझे क्या निकालना है? m. तो I write formula for m. M is equal to 1 upon 4L square into T upon n square. And now I can substitute the value. So I write small m is equal to 1 upon 4L square. L कितना है? 0.5 square into T कितना है? 5 into 9.8 divided by n square. n कितना है आपका? 100 square. Okay, solid 1 upon 5.5 plus square 0.1 into 5 into 9.8 divided by 100 square is 10 raised to 6. Then here, see, do the multiplication. 4 multiplied by 25. Clear? So what I am getting? 1. Here, 5 into 9.8. 5 8s are 40. 4 carry. Here I have 49 divided by 10 raised to 4. Means मेरी linear density कितनी आ गई? 40 and 49 into 10 raised to minus 4. Linear density. So linear density is kg per. हम लोग ऐसे भी ले सकते हैं. So 4.9 into 10 raised to minus 3 kg per. That is also correct. Clear? ये तो बहुत ही simple हो गया. Fine. Next. And now see the last problem. What is last? The string of guitar is 80 centimeter long and has a fundamental frequency. String of guitar. String of guitar means ये string vibration हो गया. तो इसमें क्या दिया आपको? String of guitar is 80 centimeter long, has a fundamental frequency 112 hertz. Fundamental frequency है 112 hertz. At that time string length दिया है आपको 80 centimeter. Clear? If guitarist wishes to produce frequency 160, अगर उसको दूसरी frequency produce करनी है तो n1 बोलेंगे, n2 करनी है, कितनी करनी है? 160. इसको L1 बोलेंगे. तो what will be the where that particular guitarist can plug the string or press the string means मुझे ये L2. Clear? Very simple. N1 is given, L1 is given, N2 is given, L2 you want to find. So what I say? Sonometer first law or string vibrating string first law. What is that? NL is equal to constant. NL is equal to constant का मतलब क्या है? N1 L1 is equal to N2 L2. Fine. N1 is given, L1 is given, N2 is given means I want to find out L2. So what I write down here? L2 is equal to N1 L1 upon N2. So N1, how much N1? 112. L1, how much? 80, but centimeter उसको मीटर में रखेंगे. minus 2 divided by N2. N2 कितना? 82 जा. 2 और ये डिविजिबल मीन्स यहाँ आ गया 56. 56 into 10⁻⁻2 मीटर, इसका मतलब 56. So where that person should press the string at a length of 56 centimeter from the rigid support, so that he can produce the frequency which is equal to 160. Clear? So like that manner we can solve the numerical problems. Fine. So now I will just recall all the things from this chapter regarding numerical formula. For how many there are numerical problem, उसमें हम लोगों को पहला कौन सा फॉर्मूला याद रखना है? That is change in phase. That is nothing but 2 pi x upon lambda, or it is equal to 2 pi small t upon z. इसमें से हम लोग फेज चेंज करते हैं. क्लियर? दूसरे इसमें we can say हम लोगों को most important thing याद रखनी है, that is if your air column is vibrating when pipe is closed, this pipe is closed at one end. अगर आपका pipe one end पे closed है, then fundamental frequency this end is equal to V by 2. Okay, then उसकी higher frequencies क्या है? That pipe will vibrate with fundamental frequency and second order frequency Pn, third second order frequency 5n, first order frequency 3n, like that manner. That is 2n, 2p minus 1 into p. ये आपका second important thing. Third is when pipe is open at both the ends. अगर आपका पाइप बोथ एंड ओपन है, at that time इसकी fundamental frequency n is equal to V by 2a, and that pipe will vibrate with higher frequency. Fundamental frequency n, first order frequency 2n, second order frequency 3n, like that. Yes, means when pipe is open at both the ends, it will vibrate with all integral multiple of fundamental frequency. But when pipe is closed at one end, it will vibrate with odd integral multiple of fundamental frequency. Clear? Okay, fine. Then fourth one, when string is in the vibration, so at that time string vibrates with fundamental frequency n is equal to 1 upon 2l divided into root t by small l. इसमें capital L is the vibrating length of the wire, T is the tension, M is the linear density of the wire, or which is also called as a mass per unit length. In this, string will vibrate with higher frequency. First fundamental frequency n, first overtone 2n, second overtone 3n, like that manner overtone frequency. Means ये string भी कैसे vibrate हो रही है? It will vibrate with all integral multiple of fundamental frequency. तो ये open end pipe, open end and both the side and string vibration, ये दोनों जो example है, इसमें they will vibrate with all integral multiple of fundamental frequency. Clear? Then उसके बाद, so हम string first law, frequency is inversely proportional to length. Then frequency is directly proportional to root 3. Seventh one, frequency is inversely proportional to root of m. M is the linear density. उसमें से दो और law. Frequency is inversely proportional to radius. Radius law. Frequency is inversely proportional to square root of density. तो ये फॉर्मूला भी होगा. फिर 8 number, with frequency n is equal to n1 minus n, or it is equal to, also it's equal to 1 upon t. Means period of bits t is equal to 1 upon n1 minus n for your bit. these numerical formulas you have to remember while solving the numerical. Clear? Go through each video 2-3 times so you will come to know the minute problems, minute things from that each video. हर एक वीडियो में आपको मैंने बोला है where the MCQ will ask, where the short answer, long answer, everything is given. So go through that video very clearly so you will come to know. This is very easiest chapter. You can understand properly, and if you have any doubt, you can ask. Okay? Fine? Chalo. So this chapter is finished. Next time I will start your next chapter. Fine. Thank you.